Hi guys, this is Vandana Bagar. Today we are going to see a very interesting topic from operating system, that is deadlock. This topic is important as well as interesting too for the students, those who are learning computer science graduates, computer engineering students as well as BTech computer students also. So let us start our today's topic, that is deadlock. First of all, let us see some background scenario related to deadlock, as we always want that my computer system should give the better CPU utilization. Better CPU utilization when I will get? When there is a multi-programming environment. In multi-programming environment, more number of processes are always compete for the finite number of resources. Every computer system is having finite number of resources. This resource can be physical resource or logical resource. Physical resources considers your printer, CPU cycle, memory cycle, and logical resources considers files, semaphore and monitor. Now let us come back to the deadlock scenario. When these processes are striving for the resources, suppose any process requires some resource for its successful execution and that resource is currently not available or not free in the system, then that process goes into the waiting state. Now, this waiting state or the process may remain forever in that waiting state because for the resource for which it is waiting, that resource is never going to release by any other process because the resource is allocated to such a process which is itself in the waiting state. That means this process always remaining in the waiting state. This situation is called deadlock. Let's understand the same scenario, same concept by a real life scenario. Let us consider two trains are approaching each other at crossing. While crossing, both the trains have to stop because they cannot move ahead. Both the trains will be stopped because both the trains are in front of each other. Such situation is called deadlock. Fond of listening stories. In any age of life, we always like to listen the stories. Now I am going to tell you one story which is directly related to our today's topic, that is deadlock. In our childhood, we heard the story that two goats are there. They are crossing a bridge over the river. Okay, one goat is coming from one side and another goat is coming from another side. Both the goats wants to cross the bridge, but both of them are not ready to leave the path. In such situation, both the goats are starting quarreling with each other, and at the end, both the goats are fall down into the river. This is the exact situation of the deadlock. In the deadlock, now let us consider if there are two processes. Now these two processes, in our first example, these two processes are nothing but the two trains. In our second story, these two processes are nothing but the two goats. Now we are having two processes, process A and process B. Okay, both these processes are executing at the same time in the computer system because we want the multi-programming environment. Now process A wants to complete its execution successfully and process B also wants to complete its execution successfully. Both the processes are executing at the same time. Now, for the successful execution of the process A, it requires the resource R1, which is already allocated to the process B. For the successful execution of the process B, it requires the resource R2, which is already allocated to process A. That means process A is requesting for the resource which is allocated to process B, and process B is requesting for the resource which is allocated to process A. In turn, both the processes are in the waiting state because for the resource for which they are waiting or they are requesting, that resource is already allocated to another process. In such situation, both the processes cannot start. That means both the processes cannot run both the processes are not releasing their resource and both the processes cannot awake. Such situation is called deadlock. Understand the system model of deadlock. As it is a system model of deadlock, obviously it requires process and resources. Process is exist because process wants to complete its execution successfully. For the successful execution of the process, it requires resources. So, for the successful execution of this process, a system is having finite number of resources. Finite number of resources means resource can be of any type, but it may have number of instances. Instances means number of forms of the particular resource. Let's say suppose there is a resource A. Now there might be the existence of only single instance of that resource A, or the resource A is having number of instances, let's say suppose 3. That means 3 different resources A are exist in the system. So likewise resources, finite number of resources are involved in the system, are present in the system for the competing processes. Whichever process is executing, that process may request for the resource. This request is satisfied if the resource is available, if the resource is free. This particular action is completed with the system called request. With the request system call, process is requesting for the resource. If that resource is free, then it is allocated to the process. If it is not free, then that process goes to the waiting state. But this action is completed with the help of a request system call. So in the system model, there is a first parameter, that is request. Now let us assume the request made by a particular process is satisfied. That means that resource is allocated to a demanding process. Now the next step is use. Use means the process or the resource is allocated to process. So process is utilizing that resource, using that resource for its successful execution. It is called as use. Now next step is process has already used the resource. Now process must release that resource so that it can be available for another processes, another requesting processes. So the next system call is release. Once the process has utilized the allocated resource, now the process is not required that resource. In such situation, process must release that resource so that it is available for the another requesting process. This action is completed with the system call, that is release. So in the system model of deadlock, there are 3 important parameters, that are request, use and release. Request and release are the system calls. Request means process is requesting for the resource. If it is free, then it is allocated. If it is not free, then the process goes to the waiting state. Use means process, resource is allocated to the process. Process is utilizing that resource. Release. Once the process has fully utilized the resource, then the process must release that resource so that it can be made available to the other requesting process in future. So in the system model of deadlock, there are 3 parameters: request, use and release. Situation: processes never finish execution. Resources are get tied up because all the processes present in the system are in the waiting state. None of the process can awake. None of the process is releasing the resource and none of the process can run. So in such situation, all the processes present in the system are never complete their execution, all the resources are get tied up, so everything is just chill down. This situation is deadlock. Now we come to the topic, that is the characteristics of deadlock. That means we can say the necessary conditions for the deadlock to occur. There are 4 necessary conditions. If all these 4 necessary conditions are held simultaneously at the same time, then we say deadlock is occur in the system. I repeat, if all the 4 conditions exist in the system simultaneously at the same time, then we say deadlock is occur. Now what are that 4 conditions? First one, mutual exclusion. Second, hold and wait. Third, no preemption. And fourth, circular wait. If all these 4 conditions exist simultaneously, then we say system is in deadlock state. Now let us understand one by one what are these 4 necessary conditions. First one is mutual exclusion. As its name indicates, the processes involved in the mutual exclusion, the processes involved in the deadlock state are mutually exclusive to each other. Now mutual exclusion or mutually exclusive to each other means all the processes must be in a non-shareable mode. One resource is allocated to a one process only. One resource is allocated to one process only. If another process is requesting for the resource, for the same resource, then that process must be delayed. Such situation is called mutual exclusion. Means all the processes involved in the system are mutually exclusive to each other. Means they are in non-shareable mode. This is the first condition. Now our second condition is hold and wait. As its name indicates, hold and wait. That means process is holding some resource and at the same time it is waiting for another resource. Hold means process is holding some resource for its successful execution and at the same time it is waiting for another resource to get allocated. Third condition is no preemption. No preemption means once the resource is allocated to a particular process, then that resource remains with that process until its complete execution. Or if that process is voluntarily release that resource after its execution, it is allowed. Means no any other process is having rights to forcefully preempt the resource from any particular process, though that process is having high priority. Though that process is having high priority. Means once the resource is allocated to a process, it remains with that process until its execution or if that process voluntarily release that resource. This situation is no preemption. Now the last condition is circular wait. As its name indicates, circular wait. Now let us understand the circular wait by a simple example. Let us assume there are 4 processes P1, P2, P3 and P4. Now in this situation, P1 is waiting for the resource which is allocated to P2. P2 is waiting for the resource which is allocated to P3. And P3 is waiting for the resource which is allocated to P4. And P4 in turn waiting for the resource which is allocated to P1. Means in the multi-programming environment, all these 4 processes are currently executing at the same time and all the processes are waiting for each other resource to release, and ultimately last process is also waiting for the first process resource to be allocated to the process P1. This situation is called circular wait. So whenever we say deadlock is occur in the system, at that time actually all these four conditions mutually are occur. Mutual exclusion, hold and wait, no preemption and circular wait. If all these four conditions are occur simultaneously, then we say the system is in deadlock state. Thank you.